here's our final example for area of a regular hexagon. So take a look. Find the area of the regular hexagon using the given information, and in this case we have the apothem, okay? So the apothem, what is that? Well, that is basically the distance from, from the center of the polygon to the side, okay? So it's going to, of course, hit at a right angle, all right? But it's the distance from the center of the polygon to one of the sides at a right angle, okay? Yeah, let's talk about what if we have that information instead. So I'm going to draw all of our triangles again, and remember the goal with this is if we find the area of one of the triangles, we just multiply by 6 to get the area of the entire hexagon. So let's pull this triangle out, okay? We know the apothem is 12, okay? We know this is 30, okay, because the whole thing is 360, 360. And again, watch the previous videos because I explain it in detail in the first video. When we drop this altitude, we end up bisecting the angle, so it becomes 30. This is 60, okay? And all right, so here's a question. If we're going to find the area of the triangle, okay, it's 1/2 base times height, okay? We don't know what our base is, okay? But we do know that our height, the apothem, is 12. So how do we get the base? All right. Well, there's 2 ways we can do this. We can go to the short leg and double it, or we can go to the hypotenuse because, well, we've talked about that in that previous video. We talked about how all of the triangles in a regular hexagon are equilateral, which means the hypotenuse is the same measure as this length here, okay? All right, so let's see. Well, why don't we go from long leg to short leg? So we know the trick for long leg to short leg is divide by 3, multiply by √3. So that's 12 divided by 3. 12 divided by 3 is 4, and then we multiply by √3, so 4√3. Okay? So then we can just double that, okay? 4√3 for the whole thing being 8√3. And again, or we can get the hypotenuse, which is 8√3, 4√3 doubled. Either way, the base that we want, this length right here, is 8√3. Perfect, okay? So now if we want the area of one of the triangles, it's just going to be 1/2 base times height. So in this case, that's going to be 1/2 times 8√3 times 12, okay? Now, I don't like dealing with big numbers. I don't use a calculator frequently because I just don't have one, and I use my phone to film, so that's my calculator. All right, so we are going to just simplify this. So 8 divided by 2 is 4, so this goes away and this becomes a 4. So now what I'm looking at is 4√3 times 12. Okay, times 12. Okay. For the area of one of the triangles, okay, so 4 times 12. If you can't remember, think about doubling 12. So 12 doubles to 24, that's 12 times 2, and then double that again, and that's going to be 48, okay? So it becomes 48√3 is the area of the one triangle, area of one triangle, okay? So now we want the area of all 6, so the area of the hexagon okay, that's just going to be 6 times 48√3, okay? So I know what you're thinking here. I need a calculator for this, help me out. Well, let's try to think about it without using a calculator, okay? So if we were to make this 50, that'd be nice and easy, right? So 6 times 50 is 300, okay? So just bear with me for a second. But then really it was 2 less, okay? It was 2 less, so we need to take away 2 less, but we did 2 less 6 times, okay? So that's minus 12. And then if you're like, oh my gosh, remember, just subtract 10 from both, okay? So then we end up doing 290 minus 2, so it becomes 288, okay? And then, of course, that was 6 times 48, so we need the √3, okay? And then we do not have units here, so we're just going to do units squared. Boom. So there's your answer. The area of the regular hexagon, when we know the apothem is 12, is going to be 288√3 units squared. There you go.